Okay, for our next video, we are going to discuss functions, and functions are relations. So they start off just being ordered pairs, but there's something special about a function, and that is that in a function, all x values are unique, which means different. So in a function, all the x values are unique. We say that their x cannot be repeated, so we could write it that way. X cannot be repeated. All right, so what that means is that for every x, there's only one y. Now, there are a few ways that we can write or show a function. First thing is just with our ordered pairs. So you've worked a little bit with ordered pairs now. So if we had 3, 7, 2, 6, 1, 5, 0, 4. If you were asked if this is a function, we're just going to check the x values. And we want to make sure that all of the x values are different. And if they are, then we would say, yes, this is a function. All right, now, if we have an x value repeated, then the answer would be no, this is not a function. So it's easy to tell when they're listed as ordered pairs. Another way we could list or show our relation would be as a table. And we usually refer to this as a t-table or a t-chart. And that's because it looks like a t. But over here we'll have the x's, over here we'll have the y's. And let's say we had 2, 7, 3, 1, 2, 9, and 0, negative 5. If we look at this one and we're asked if this is a function, again, we are going to look at the x values right here. And when I look at these, I notice right here and right here that I have two x's that are repeated. So this would be no. This is not a function. Because remember, for it to be a function, all of the x's must be different. All right, another way that we can display this is in a map or a mapping. So whichever you prefer, map or mapping, it's the same idea. What we're going to do here is we usually have two ovals. This one is going to be our domain, and this one is going to be our range. And I am just going to put some numbers in here. Let's see, 7, 9, 10, negative 2. Alright, so I'm going to just use an arrow to show which one goes with which. And there. Now, if I was asked if this was a function, what I want to do is make sure that each x is only used once. So that's only used once, 2 is only used once, 3 is only used once, and 4 is only used once. So right now the answer would be yes, that this is a function. But if I had another arrow like this, now 2 is used twice. It's used to match up with 9, and it's used to match up with negative 2. So in this case, the answer would be no, that that is not a function. And the reason is because 2 is used twice. So remember that in order for it to be a function, all of the x values have to be unique. All right, the last way that we could do or show a function is on the graph. And obviously what we would do there would be to plot some points. So let's see, we'll just sketch a little graph here. Let's say I have that one, we'll do this one, and maybe down here. Alright, when I look at this, I see this point has -1 as its x. I see this point has 0 as its x. I see this one has a 1 as its x, and this one also has a 1 as its x. So what that tells me is that this is not a function. Now, we have something called the vertical line test, and basically what that says is that if I have 2 points on any vertical line, then it's not a function, because 2 points on a vertical line are going to have the same x values. So this is what we call the vertical line test. And that is just a way to make sure that all of the x's are different. Alright, I think that covers everything that you need to know about functions. Again, if you need to watch the video again, please do. If not, then you're ready to pick up your sheet on function.